After you've decided what population you care about finding information about and what your parameter or parameters are that you'd like to measure, you need to start collecting data. And so we're going to talk about different ways that we can collect data. So first, we have this definition of what's called a census. A census is a survey of the entire population, meaning every single individual in the population you go and you collect information from. Okay, you ask questions and you record information about every individual. That is a census. Now, censuses are not extremely common because going to every individual in the population of interest is going to take a lot of time. It's going to take a lot of money. It's just really hard to do unless, of course, your population is tiny. Maybe your population is just students in your current math class. In which case, then a census would be quite simple to do. But generally, censuses are not super efficient ways of collecting data. It's very useful data, of course, if you can get a census, but it's not super common. It's so hard to get information about every individual in the population, we're actually going to use samples. And a sample is a smaller subset of the entire population. So we don't get information from every individual in the population. We just get a group of individuals from the population, and that's what we call a sample. And the best types of samples are those that are representative of the whole population. So, for example, if I'm interested about knowing something about full-time teachers, then I would try to get a sample of teachers in a lot of different types of schools, different grade levels, different socioeconomic regions. Okay, I wouldn't want to go and ask all the teachers in one elementary school in an affluent area. Okay, that wouldn't really be a good sample if I'm trying to find out something about all full-time teachers. So that's what a sample is. And when we collect data from a sample, we of course are trying to estimate some parameter, some type of average or percentage or something. But since we don't have information from the entire population, the number that we calculate based on our sample is called a statistic. All right, the statistic is the value that's calculated using data from a sample as opposed to data from a population. And this is why the whole area of statistics, we call it statistics, because we're talking about using numbers from samples to give us a good idea of what's happening with our population. So let's look at an example. A researcher wanted to know how citizens of Tacoma felt about a voter initiative. To study this, she goes to the Tacoma Mall and randomly selects 500 shoppers and asks them their opinion. 60% indicate they are supportive of the initiative. What is the sample and population, and is the 60% value a parameter or a statistic? So we'll talk first about our population sample and identify those. That's always going to be kind of your first step in either designing a study or analyzing a study. So our population is the group that we actually care about knowing something about. And this specifically tells us that our researcher wants to know how citizens of Tacoma feel about a voter initiative. So the citizens of Tacoma, that's our group of interest here. So our population is citizens of Tacoma. Now, this researcher doesn't get information from all citizens of Tacoma. The researcher gets information just from some of them and goes to the Tacoma Mall and randomly selects 500 shoppers and talks to them. And so those 500 shoppers, that's who we actually get data from. And so that is our sample. 500 shoppers at the Tacoma Mall. Okay, then we want to talk about this 60%. And we want to know, is that a parameter or a statistic? So the question really is that 60% describing the population or is it describing the sample? Well, we're told that the 60% of those 500 shoppers, after talking to them, we find that 60% of those shoppers were supportive of the initiative. And so that is a statistic. Because it doesn't necessarily describe the entire population, not all citizens of Tacoma. It describes just those that we actually got data from. Look at another example. To determine the average length of trout in a lake, researchers catch 20 fish and measure them. What is the sample and population in this study? So, our population, I think it's usually easiest to identify the population and probably best to identify the population, since that's kind of the starting point of any study. The population is the group of individuals that we actually care about knowing something about. And here we're told that we're trying to determine the average length of trout in a lake. So that means that our population is trout in the lake. Okay. Our sample is the group that we actually obtained information from. And this is, well, the researchers went and they caught 20 fish and measured them. So that's the 20 fish that were caught. And that's the information that's being given, that's being used by these researchers. A college reports that the average age of their students is 28 years old. Is this a statistic or a parameter? Remember, a parameter is a number that describes the entire population, and a statistic is a number that describes a sample, some subset of the population. Well, this college is reporting the average age of their students, and we're going to assume then that, of course, that college doesn't care about the average age of other students. They care about the average age of their own students. And so the population we would expect for this college to be the students in that college. And they're reporting that the average age of their students is 28 years old. They're not saying some of their students. They're saying of all of our students here, our average age is 20 years old. And so that is a number that describes the entire population, and so that is a parameter.